All right, chapter 4 is all about triangles. And in case you're wondering, we still get to do proofs in chapter 4. So if you're worried about not having to do proofs, you can rest easy. But today we're going to talk about triangle sum properties. And when we talk about sum, we're going to be talking about the angles that are inside of triangles. We're also going to talk about the basics of triangles and the different types. For instance, we talked about polygons. We talked about being equilateral or equiangular, and you'll see some of those terms come up in here as well. So again, I said we'd classify some triangles, talk about the basics. So there are two ways to classify a triangle. You can classify them by their angles or by their sides. So if you look at the ones we classify by angles, okay, we have a right triangle. Obviously you can tell that, well, that's going to be a triangle with a right angle. Obtuse triangle is going to have one obtuse angle. Later you'll find out it's actually impossible for a triangle to have more than one obtuse angle. An acute triangle will have all three angles acute. Again, acute being less than 90, obtuse being greater than 90, so this would be that obtuse angle. And then equiangular triangle, which again, you should be familiar with that term. That is when all three angles are congruent. You can also classify triangles by their sides. So here, we have scalene that has no congruent sides. Okay, we got 1 dash, 2 dashes, 3 dash. That indicates that they are all different sides, so no congruent sides. Isosceles is going to have at least 2, so at least 2 sides are going to be congruent. And equilateral, again, a term you should be familiar with, that means all 3 sides are congruent. So, an isosceles triangle is not necessarily going to be equilateral, but an equilateral triangle is isosceles, because an equilateral triangle has all 3 sides congruent, which would also make it isosceles, so you only need at least 2. So those are your different types of triangles. So it says classify a triangle by the sides, determine if it's a right triangle. So to classify by the sides, we've got to figure out if we have any sides that are congruent or not. Well, on this one, you can count this length. We go from -8 to 3, so that has a length of 11. These other two, you're going to have to do some distance formula. So for these points here and here, we'll call them A and B. If we go do distance formula and subtract the x's, so -8 minus -7 squared plus, look at the y's, we got 2 and 7. So 2 minus 7 squared. And that's all going to equal out to, let's see, 1 plus square root of 26. So it'll be 5.1 or something like that. And then if we find BC here, again, distance formula, subtract the x values. Well, we got 3 and -7. And then our y values, 2 and 7. So 10 squared is 100, 5 squared is 25, it would be a square root of 125. So all 3 sides are different, so that's going to be scalene. And we're going to determine if it's a right triangle. To do that, you got to look at the slopes, opposite reciprocals, right? So let's examine all our slopes. This one looks like we're going up 2 and over 4, up 1 over 2, so slope of 1/2. This one, we have a slope of 0. This one looks like we go up 5 left 1, so -5. So we don't have any opposite reciprocals, so it's not a right triangle. So we're just going to say it's scalene. So pretty simple, using distance formula, looking at your slopes. You need to calibrate. All right, a couple theorems. This first one is hugely important. This one is 2. However, this one we're going to use much more. So this one simply says, triangle sum theorem. The sum of the interior angles of a triangle is 180 degrees. So if we add up all three angles on the interior, so interior would be this angle, and this angle. If you add those up, it'll always be 180. So when we said earlier, we can't have a triangle with two obtuse angles, because that would mean you'd have a triangle with two angles greater than 90. Well, if you have that, then you have more than 180. So can't have it. Next is your exterior angle theorem. So this says the measure of an exterior angle, so that angle is angle 1, is equal to the sum of the two non-adjacent angles. So this would be your adjacent angle. These two are the non-adjacent. So we say that measure of B plus measure of A is going to be the equal that exterior angle, that angle 1. Exterior angle is always made when you extend one of those lines. So we say this angle is exterior. It's going to be equal to these two added up. Next, we have what's called a corollary. There are just a couple of these that we'll put in that notebook this year. A corollary is simply a statement that can be proved or proven easily using the theorem. Okay, so it says the acute angles of a right triangle are complementary. So we will be proving that today. So if you have a right triangle, these angles are going to add up to 90 degrees. So let's prove that theorem. And we're going to start with our given. So what's given? What does this symbol indicate? This indicates a right angle. Doesn't say 90. It says you got a right angle. So we'd say angle C is a right angle. That's given. Which then means measure of angle C equals 90 degrees. So that's just simply definition of a right angle. Alright. So then we got to think, okay, how are we going to prove that A and B add up to 90? Well, what's something we know about our angles of the triangle? You should know that all the angles are going to add up to 180. So measure of angle A is measure of angle B plus measure of angle C equals 180. And that's that theorem 4.1, angle triangle sum theorem. Step 4, well, we do know that C is 90, so we're going to substitute. Measure of angle A plus measure of angle B plus 90 equals 180. So that's substitution property of equality. Then step 5. Now, hopefully you're thinking about what we're proving here. We're proving that A and B add up to 90. So the next step should be able to tell us if we subtract 90 to both sides. So measure of angle A plus measure of angle B equals 90. And that's subtraction property of equality. So then, finally, we can say angle A and angle B are complementary. That would be definition of complementary angles. And I need to calibrate my board. There. Yes, it's on. Alright, so there's a proof. Couple examples solving for x and y. So on this one, we got right angle, we got 36. Well, if that's a right angle here, this must be a right angle there, which means y, we can take 180 minus 90 minus 36, and we'll get y because these three need to add up to 180. So 90 after you get rid of that, and subtract 36, you'll be down to 54. Now we got to figure out this measure. Well, we do know, we look at this triangle here, 15, 54, we can figure out that angle. 180 minus 54 would be 136. No, 180 minus 54. 130, 126 minus 15 is 111. And so if that's 111, we subtract that from 180. So x is going to be 69. No snickering. All right, next one, number 2. Supposed to solve for x and y, and then find the measure of angle DEF. This one we're going to use our exterior angle theorem, which says that our exterior angle is going to equal these non-adjacent ones added up, or the sum of these non-adjacents. So we can say 3x plus 6 equals x plus 80. So 2x plus 6 equals 80. 2x would be 74. So x is going to be 37. So then we can do 180 minus 80 minus 37, and we're going to get 63 for y. And then if we want to find the measure of angle DEF, well, we simply plug in 37, so 3 times 30. Oh wait, you know what would be much easier? This is 63, subtract that from 180, and we're going to get 117. So no need to actually substitute in there, although you could, and you should still get the same answer. All right, and that will be your assignment. That'll be due on Wednesday. Hope you had a good weekend. Mine wasn't so great because I didn't shoot a deer, but hopefully as I make this video, you guys are all bagging a big buck. See you tomorrow.